our next speaker. It's Grahame Grieve from Australia. Grahame is the inventor of HL7 FHIR, and he's also co-author of the preprint Converge or Collide, recently published by GMIR. And Grahame will take us through his vision on how we can make HL7 FHIR and openEHR work better together. Grahame, please, the floor is yours.
Hello. So first of all, apologies for the poor lighting that I have. I'm actually out in the country, Australia. I thought I was going to connect with Starlink and we all set and everything, but Starlink is heavily tree blocked where I am camping at the moment. So I'm hiding in the car in the middle of the wilderness where I have mobile phone signal. Now, let's see. Let's share my screen. Can I even do this? I can. Oh, all right. Here we go. So, now you can see my screen, yeah? I think you can. Okay, how can we make sharing using openEHR with FHIR easier? So I want to start by saying that openEHR is very impressive community, impressive specifications, impressive work. And from my point of view, it was a trailblazer in creating open content and open community. And I always thought I had a really solid health informatics base. And I've recommended over the years that if people really want to understand health informatics really thoroughly, that they should read particularly the openEHR introduction and learn how openEHR works. I've run into lots and lots of variants of archetypes and thought that openEHR really mastered the design of what an archetype is. And it's been a long time now, and the openEHR toolchain has stood the test of time. So done some really great stuff. And I had a long, hard look at openEHR back when I was creating FHIR and shamelessly stole what I thought were its best features. And copying on from openEHR with FHIR, a strong focus on openness around community and license and tooling and our engagement with social media. We built FHIR based on HL7 community and experience. Like a number of other approaches, including openEHR, we use two-level modeling. In the case of FHIR, we use resources and profiles instead of the reference model and archetypes. So I'll come back to that. We have a really growing implementation ecosystem that's very active. And I invested deeply in conformance tooling. And I think we're by far the furthest ahead in that area. So that's kind of where we are. Just in terms of continuity, you see that they really have a very similar approach in that openEHR has a reference model that defines the content that you can exchange, and then constraint models in which you add additional meaning as ways of using the reference model with archetypes and then templates. And in FHIR, we have resources and profiles which serve the same function as both archetypes and templates. And they have different levels of abstraction. The reference model in openEHR is more abstract than the resources in FHIR, and we put a lot of thought into that and why that is. And but the methodology, the approach is very similar. And I think about what we're trying to do and what openEHR is trying to do. They're different things that they're trying to do. And one word that I use sometimes to capture this is the idea of interoperability. So interoperability is the ability to exchange data between different systems and successfully make use of that data, whatever that means. I use the word interoperability to describe the ability to exchange data between different instances of the same system. That's what openEHR is trying to get at, is interoperability. And there's a culture question, a values question at the heart of this. But the purposes of FHIR and openEHR are different. openEHR is about content data, content record management for EHR systems, openEHR. With FHIR set out to do all healthcare data exchange. There's a bit of an overlap between them in that you could do record exchange between EHRs using openEHR, or you could do it with FHIR. Even then, in that overlap space, you still have pretty clear differences between why you would choose one or the other, but they're not always clear to everybody, and so there's a bit of confusion in that space, and maybe we have an opportunity to do something about that. But they're not, like, you can't solve openEHR's target problems with FHIR, not as it is, and you can't solve FHIR's target problems with openEHR, not as it is anyway. They're doing different things. And there's a values question here to a degree. And I've had it put to me, and this is not an uncommon thing to hear, that interoperability is a bad idea. It's trying to close the gate after the horse has bolted and it's long over the horizon, and you're now looking at the gate going, how do we fix this up? The best thing to do is to get the systems to agree on content up the front. And then if they all have the same data, they really don't have an interoperability problem. So I'm game to agree with that. I mean, even if everybody agrees on the content, you're still going to have protocol challenges and mapping from business requirements and business processes to data exchanges and matching and limiting the amount of data you're going to exchange. But hey, if everybody agrees and uses the same data, you're a lot further ahead. And I've had people criticize FHIR and say, well, really, you're solving the wrong problem here. And look, from my point of view, in general, the earlier you can agree in the process, the better off everyone is. But the healthcare system that I know, that I work with around the world, is characterized by being unable to get agreement. And so our view in the FHIR community is, sure, the more you can get agreement earlier in the process, the better off you are. But messy interoperability isn't going away. So having said that, let's look again at FHIR and openEHR. From my point of view, the semantic basis of FHIR was weaker than I thought it should be. The community never invested as much as I thought it should in that. But I can't do everything, so I didn't do that. Clinically focused design tooling is absent, or nearly absent, from the FHIR community. And I thought someone would step up and do that, and left it to the market, and maybe I regret that. I thought really somebody would invest in doing that. I think someone still should invest in doing that. Now, another thing is that FHIR is not a full-fledged semantic or technical basis for writing a clinical application. It was never meant to be. We didn't set out to write an application development stack. And it turns out people are doing a lot of that anyway. I mean, there are some serious nationwide, country-level clinical applications running on a FHIR backend server with a few other protocols, SCIM and LDAP and a few other things thrown in. And they're treating it as a way to write a clinical application. We never set out to do that, and when people ask me about that, I'm like, it's not what we wrote it for, and it's not what we prioritize in the design, but if you want to do that, knock yourself out. And people have done some pretty amazing things. But it's pretty interesting because I used to teach that there's a trilemma here, cheap, flexible, and interoperable, that you could have any two. Only it turns out that people are using FHIR to produce applications that are cheap and flexible and interoperable, but they're not very robust. So it's actually more complicated than the trilemma that I used to teach, that there was a compromise between all those three. I'll figure that one out. But so, like, we didn't set out to solve the same problem. The fact that people are using it, whatever. But on the other hand, and so one of the things I often hear about FHIR is there's too many profiles, and that a design goal, or should be a design goal, for FHIR to eliminate that. The problem from my point of view is that there should be one profile per use case, and actually characterizing use cases and figuring out whether they're aligned. Actually, that is the problem. That's the hardest problem. How do you know, are they aligned? Who decides that there's one profile, that these two use cases are the one use case? And that requires very intimate knowledge of them. And you need to know the functional and non-functional requirements and the life cycles. And so I think that it's easy to criticize the community and say there's too much disagreement, but actually it's pretty hard to herd the cats. And of course, in FHIR, we'd love to see more clinical design, although the clinical community is not ready for prospective top-down design standardization. They're still like very resistant to that as an idea at the clinical level. So it's bottom up, chipping away at it, which openEHR is doing a really great job of. In terms of openEHR, I'm going to make some comments about openEHR. So openEHR Masterclass, so maybe you might be very not happy about some of these. We can talk about them. But one of the things that I see a lot of in systems and in FHIR designs and in CDA and in openEHR, because I've done a little bit of openEHR design work, is that we trade between text and structure. So we have a problem and we're going to deal with all the clinical span of the problem, and everybody's going to deal with that. And in order to do that, we do an analysis and decide which data elements we're going to have and which we're not going to have. And we kind of shove everything else that we didn't have for data elements into a text field. And the things that people pull in and pull out differs by analysis. So this is kind of idea that if we could have a single master model that accounts for everything, but we can't, because what people put in text is uncontrollable. Unless AI comes to the rescue, and I thought Sidharth was mainly on the ball with where we are with AI, and I'm not sure that it's coming to the rescue absent some fundamental conceptual advances in what AI is doing. We're still going to be in a mess trying to pull data and align and reconcile data out of text. And so it's really, like, people know this is not exactly a surprise, but it just keeps coming up and up and up for me when I'm doing implementation. And the thing about openEHR is this is a single process, whereas I look at where we are and say there's some things that we want to spend millions of dollars getting a rock solid consensus on. And some things, actually, we're just a bunch of friends who come to an agreement and we just want to record that agreement. We don't need any process. And it's a spectrum. HL7 used to be like, well, there's only the rock solid $1 million consensus, everything else is worthless. But that was the old HL7. HL7 now is much more about what's your scope. I think openEHR needs to have a broader view of this. Now, this is something that I've spoken about before at openEHR and in public. openEHR has, no, I want to go back there. openEHR has a very rudimentary terminology binding methodology, whereas FHIR has developed a really well-developed terminology ecosystem. We put a lot of investment into terminology ecosystem, and we have public servers and national servers and service specifications and a very wide availability of terminologies and a whole layer, a cascading layer of control over that. And in fact, what I discovered when I looked into this last year is that real-world openEHR implementations are actually using the FHIR terminology ecosystem. But when I looked around, what I found is they're all doing it a little bit differently. I really think openEHR should formalize this and actually use the FHIR terminology framework and formalize it in ADL. we can do more to support that. I'll come back to that. And the other thing about openEHR is I worked back when I was actually a working CIO, CTO of a clinical systems vendor. We had an Archetype system. There was no question that what we were doing was archetyping, and the system was parallel to openEHR. The semantic base, the elegance, it was really rudimentary compared to ADL. But the thing that really struck me when I was looking at openEHR and comparing with the system that I used to run and hire and fire programmers for was that 90% of what we did in the system was about forms, presentation on the screen, presentation on paper, mapping to external formats, engineering the content of the archetype into the system. And it was hard work. And people could come along and say, I want to change the archetype. And yeah, we could easily change the archetype, but you just had this long tail of actually the engineering. And I just look at openEHR and think openEHR should do more about formalizing the support for this, and I'll come back to that. So I think we could work together, and there's some various spaces, 5 different ways in which we could work together better. One is that we could do a better job of mapping from archetype storage to FHIR interfaces, which is a theme that's come up. We could do better with terminology usage. We could use openEHR tools in the FHIR ecosystem. I'd love to do that. We could use FHIR tools in the openEHR ecosystem. I think that would be a good idea. We'll talk about that. And we could collaborate organizationally. So mapping archetypes, you can convert archetypes data to a FHIR API by writing code in both in and out data. And so you have an openEHR backend archetype with a whole bunch of data stored, and you want to put a FHIR API over that. It's a very classic, very common thing to happen now in openEHR systems, because kind of like openEHR is a really great way to design a system, and FHIR is a great way to do an API that's interoperable and meets national specs or so forth. So you can do that. And typically, like all conversion processes, 90% of the data is easy, 9% of it's tricky, and 1% you just throw your hands up and go, I hope no one ever really cares about this data because I just don't know. That's a pretty typical spread in that case, because 1% of the stuff, who knows? But what really stands out to me about that process is that everyone starts from scratch every time, because mapping expressions and the engines that run them are just not portable, and there's no way to share knowledge. And it would be really good to do better and write the mappings between ADL, between the archetype and the best optimal recommended FHIR resource representation into the archetype itself. Now, that's a bit tricky because mapping itself is hard work. And when I look at a set of mappings between 2 different models in 2 different conceptual frameworks, what I've come to the idea is that there's 4 levels at which you might do this mapping. One is skeletal mapping. You're really just marking out the high points, making decisions between the major classes or groupings and saying, oh, this group of stuff here is this group of stuff over here, and hey, this one's a bit tricky, so I'll tell you where this one lands, and we'll leave the rest as an exercise for the implementer. We just pointed them in the right direction. I think of that as a skeletal mapping. And then there's conceptual mapping, where we run through every field and we map every field based on its definition. So a definitional mapping, and in FHIR we use concept map. We have an actual representation for that level. So a conceptual mapping. But that mapping doesn't actually get into the data details and say, look, it's a value domain of this and a value domain of this, and are they compatible? Are they actually all the data mapped? So a detailed mapping is where you go down to the primitive level and you account for the full value domain and you do the mapping. But even them, they don't have special logic, special cases. That last stinking 1% where you're just going to write code, write special logic. If you're going to do that, you're going to get down to an executable mapping, and that is where you've got all the logic captured and you can execute that directly and just feed it into a machine, data in, data out, and it's transformed. And the idea is, and we actually have something in FHIR for that, because FHIR mapping language, which is at the executable level. But it's hard work to get down to that level. But it's hard, whatever you do. The idea for me is to make mappings portable. And so from my point of view, it would be sensational if we could work together to extend either ADL or tooling, or both, to specify the whole mapping, although we'd have this big long discussion about conceptual versus executable. But ideally, we can make it possible to maintain the conversion logic between ADL, the archetype, and a FHIR representation integrated into the design process. And you wouldn't just do that for FHIR, you could do that for version 2 and your local government's weird EDM format that you have to submit in, and all of these things. So that's what you do with archetypes, is move data in and out of them. And some of those would be national standard move data in and out of them, so you could do that there. I think that would be a good investment for openEHR to make. And it's not that this doesn't exist at all. There's some parts of this in ADL, totally. I just think it should go further. And also, I think on this subject that since FHIR interop is becoming more ubiquitous, designing for that should be part of designing, mapping, designing an archetype. To say, we're going to do this, so we'll have a good look at the FHIR resource, whether we like it or not, and design so that we can map to it. So that's mapping. Now, terminology, I didn't see this. Well, I haven't kept up with the participants, but this is from a German project where you're mapping between an archetype here and, what do you know, a FHIR terminology code system. And, well, it turns out that you're mapping to the FHIR terminology services here. And when I got digging into this, I discovered that, well, there was a number of problems with this because it's not really integrated. Now, in FHIR, when it comes to terminology usage, we bind from the model or the archetype to the terminology, and we have level strengths of mapping bindings, and we have multiple bindings with user interface and decision support and context-specific bindings and multilingual bindings and min-max legacy bindings. You don't know what they are, that's fine, but they come. All this complexity happens. We didn't like it and we resisted it, but it happens. If you're going to design interoperable specifications that deal with real-world systems, you have to do these things. And we have integrated value set definition and expansion and a full-fledged terminology service ecosystem. And so there's a lot of drive to make those things available and use them in ADL. But what I discovered is the bindings are just not well described. And because they're not well specified, the work happening between different projects is not very interoperable. It's not very tooling supported. And in fact, I found, tech problems looking into it. And one of the things we did in FHIR, which we'd love to extend into openEHR, is to establish a culture of saying what your terminologies are and checking them and enforcing them and not tolerating errors and broken links. And it was a big lift for the FHIR community to get that. And so I would love to work with the openEHR community to get a really well-described, well-supported binding. There's some things you have to do to adapt the FHIR terminology framework to openEHR because the actual data represents terminologies differently. Now, we have experience with this, but we just haven't done it for openEHR. We'd love to make this work. Moving on, I love CKM. It's a great community consultation tool, and openEHR has other useful design tooling. It turns out that FHIR profiles can be represented as ADL. The constraint languages of structure definition in FHIR and ADL are pretty close to interconvertible. There's a lot more metadata, a lot more data out of ISO 11073 in profiles. And ADL has a few features that are not widely used that we don't support. For instance, choice on the entry point at the root of the model. We don't do that in FHIR. But otherwise, they're pretty interconvertible, and I fooled around with it a little bit, but I haven't kept up with it. But we could. And FHIR needs the more non-technical community consultation. So I would love to see us using CKM and other openEHR tools based on ADL as community consultation tooling. But it does mean a different reference model rather than the openEHR reference model. And that's not a small lift. And so it hasn't happened yet. But I would certainly like to find a way. And as I said, this kind of this clinical community consultation, I let the market go on this, and maybe I'm going to have to do something about it, but I don't know what. But I would love to be more collaborative with with openEHR in this space. Heading to another view, FHIR tools in openEHR. Now we have some pretty good tools in FHIR. I haven't mentioned all of them, but we have a validator in multiple languages. We have a validator that checks instances are valid against definitions. And the validators are fully terminology capable, hooked up to the whole terminology ecosystem, and a very, very powerful tool to ensure consistency of behavior. And we put a lot of effort into maintaining that. And it, as I said before, it's a big lift for the community to get used to having terminology fully integrated, but it's starting to really pay off now. And we have the IG publisher and other publishing tools, including Simplifier, that build on the validator, and they provide a way to publish a set of designs and do packaging and distribution, and the set of designs are human and computable, processable. openEHR has some of these things, but it's missing some of these things as well. The interesting thing is you can use these tools with archetypes. Wait, everybody says, what do you mean? So I'll show you something. The latest CDA specification, which is another spec published by HL7, is still CDA, but under the hood, it's actually FHIR. So all of the content of CDA, the document, is described using FHIR under the hood, and the FHIR validator validates CDA documents. And so HL7 is moving its validation process from everything else to the FHIR validator for CDA, more than anything else for the terminology purposes. So we could totally do that for openEHR. I've already have a project where I'm working on defining the openEHR reference model as a set of FHIR structures, and then the archetypes, I can convert them to profiles on the reference model. And then the validator, the standard FHIR validator, we can tell it about the openEHR instance format, and bingo, it will work with openEHR. I think somebody needs to mute. That would totally be possible. Now, let's talk a little bit about organizational collaboration, and I'll be finished. HL7 and openEHR have different communities of influence. There's countries and communities where openEHR has zero traction, and HL7 has quite considerable traction, and then the converse is true as well. And we can surely collaborate and work together in this area. It would be lovely if we could, and maybe we can. HL7 has considerable experience around regulatory experience and conformance tooling and testing and the processes that go with that. That is not a strength of the openEHR community, whereas openEHR community has really good relationships with clinical communities. Well, let's just say that's not a strength of HL7. So we could collaborate organisationally, and maybe we'll have the opportunity to do so. These things are all things that we could do and that maybe we're talking about. So let's see what comes. It would be lovely to see that progress. So to summarise then, both openEHR and FHIR have significant international communities. We have different perspectives. but also some overlap at multiple levels, and we could learn from each other, and we can work together if we want to make the overall health IT landscape easier for implementers. And we should, totally should, but it will require exercise of will from both sides. Thank you, Jan. Back to you.
Thank you, Grahame, for this very interesting presentation.